Till now, we discussed the definition of DFSM, its configuration, transition functions, yield, computations. Now let us design some simple deterministic finite state machines. Let us see an example. The language containing all possible strings of A's and B's, that is alphabet is A, B, and the string W contains substring AAB. That is, all possible strings will be having a substring AAB into it. Let us see some possible strings in this language. So the possible strings are, the first string can be AAB or AAB followed by A or a B, AAB. So before the substring I can have a or B, accepted. AAB, after that I may have some string. Before AAB I can have some string. This string is also must be accepted by this DFSM. Similarly, AAB, before AAB and after AAB I may have some substring. So these are the possible strings in this language. Now we are supposed to design a deterministic finite state machine which accepts all these strings of this particular language. So how to design? So there are two steps. First step is satisfy the language. So what are the language states? W containing substring AAB. What is the first string accepted by this particular string of this language to be accepted by DFSM? AAB. String length is 3. Then initially we need 4 states to design a FSM for this string AAB. So let us start designing. This is the initial state 0 going to state 1 with first input symbol A, then from 1 to state 2 second symbol A, and to state 3 for symbol B, reaching the final state. So we got a compulsory substring AAB reaching the final state. Is the DFSM complete? No. Why it is not complete? As we know, the DFSM will be having the transitions such a way that from each state there will be one compulsory transition for each input symbol. So in the second step, what we are supposed to do is we have to have those compulsory transitions without violating the language. So let us start with initial state 0. From initial state we have a transition for A going to state 1. What about B? So B, what happens if I take B as a self loop to the same state Q0? What happens? So before AAB I may have any number of B's. Does it violate the language? No, because AAB is a substring. Before that I can have anything. After that also I can have anything. So from state 0, one transition going to state 1 and another transition B going to state 0. So next let us go for state 1. State 1, one compulsory transition to A going to state 2. What about B? Can I take a self loop as I have taken for state 0. What happens? Let us check. If I take a self loop, then what happens? I may have AAB if I don't take this loop. What if I take this loop? A, B, A, B. Now you can see here, this self loop will violate the language. It will not have substring AAB. It will be having A, B, A, B. But we want one compulsory substring AAB in this particular machine. Then this self loop I can't take here. So next what to do? Can I take a transition here? Just what happens? I'll be having compulsory string A, B. And if at all after this first A, if at all I come across a B, then it must go back and then again it must have a substring A, B. So I hope it's clear now. From state 1, one compulsory transition going to state 2 for input A, and for B it is going to state 0. So state 1 is over. Next come to state 2. In state 2, for B I have a compulsory transition to state 3. What about A? Can I take a self loop? Yes, I can take a self loop. Let us see. What if I take a self loop here? If no self loop, then we have A, B. If we have a self loop, then that will be A, B. Ultimately, we will be having the substring A, B. So state 2 has one transition to A, one transition to B. Coming to state 3. So for state 3, can I take a self loop for both A and B? Yes, I can. Why? Because the language states it must have the substring AAB. I have a substring AAB reaching the final state. After that, I may have any number of A's and B's. Still, this string will be accepted. So, now if you see, the DFSM is complete, which accepts all the strings containing substring A,